Section 7.4, estimating the population proportion with confidence intervals. So confidence interval is one of the two big main key ideas that we're going to talk about for the rest of the semester. We've got confidence intervals here in Chapter 7 and hypothesis tests in Chapter 8. So these are two big ideas, again, that we're going to keep using over and over again throughout the rest of the semester. So this is just our introduction of doing them with proportions. Okay, so a confidence interval is the range of plausible values for a parameter. It's the estimate, like that statistic, that estimate that you get, plus or minus the same amount. The margin of error is that plus or minus amount. And we are going to assign different confidence levels to the different intervals that we make. Your confidence level is the level of confidence that you have in this confidence interval that you create. Okay, so first we're going to look at basically the brute force method for creating a confidence interval, and then we are going to, after that, turn our attention to letting StatCrunch make these for us. But the brute force method really helps you to understand how they're being created and where they come from. So for this example, we have the Pew Research Center took a random sample of 446 registered Democrats in the U.S. in 2013. In this sample, 57% of these 446 people agreed that the news media spends too much time on unimportant stories. Here, we do not know the population parameter P. We do not know the amount of Democrats in the whole U.S. who agree with this statement, but we do know P hat. We know that sample proportion. In the sample, we had 57%. So we're going to use that number for calculating the standard error. We're going to do this square root of P, 1 minus P over N. Right now, we are just sort of taking it for granted that we do meet the conditions here. I'm glossing over that right now because that's not the focus of what we want to talk about, but we could go through and check all of the conditions, and we would meet all three of the conditions to satisfy the CLT, and we would be able to use this formula. So I'm skipping over that part to get to something a little bit more interesting here. So this one is the 0.57 times 1 minus that, which is 0.43, over the sample size of 446. And we can do this and find out that that standard error is about 0.023 or about 2.3%. So again, because the sample size is large, this is going to be pretty close to being normal and centered around the true population parameter value. Again, thanks to the CLT. We're saying, yes, we can use that in this case. Thus, if it's normal, we know some stuff about normal distributions. We've got that empirical rule that we learned way back in an earlier section. The empirical rule applies to normal distributions, and it says that there's a 68% chance that P hat is closer than one standard error away from P. That there's about a 95% chance that it's within two standard errors, and that it's about 99.7% chance that it's closer from 3 away. So that was when we were using this, and we would go within 1 is 68, within 2 standard errors away is 95, and within 3 away is that 99.7. Okay, so if we look at the 3 standard errors, standard error is this 2.3%. So if I have 3 of those, that is 6.9%, 3 of those standard errors. So it says we can be almost certain that the true value of P is within 6.9% of 57. So we could go through and both subtract and add that on and arrive at these two values. So what we've created then is a 99.7% confidence interval. This is the confidence level. That's how confident we are in this. And the interval itself is between 50.1% and 63.9%. So the way that we write our conclusions then of these confidence intervals is we would say something like, we are 99.7% confident that the true proportion of fill in the blank. So what are we talking about? We are talking about Democrats who, and instead of explaining it all again, they're who think that the news media spends too much time on unimportant issues. I'm just going to say who feel this way and kind of refer back to above. So we are 99.7% confident that the true proportion of Democrats who feel this way is somewhere between 50.1% and 63.9%. That is your confidence interval. And something that's very important to note is that sample proportion, the number that we got back, that 57%, is right in the center of this confidence interval. 57% is dead center between those two values. That's where the confidence interval comes from. It's built off of that sample proportion plus or minus a certain amount. Okay, so that confidence level, in that case, that 99.7%, that tells us how often our estimation method is successful. It tells us how often the confidence interval based on a random sample will capture the true value. How often will we actually capture the real value inside this confidence interval? 99.7% of the time it's saying the true value will be somewhere in between here. And it measures the success rate, again, of the method that we're using, not of any one particular interval. Because, again, particular intervals are just like random samples. Any one of them could hit or miss it. But we are confident in the method that we are using. Now, as far as the margin of error, it says you can select how much error you'd like to allow. But too much or too little are not particularly helpful. So what we've seen are the three kind of standard ones. We've got a 68% one, which is one standard error in each direction, a 95% confidence level, which is two standard errors in every direction, and 99.7 is 3 in each direction. This one ends up being the most desired. It ends up being the most widely used because by increasing to an extra standard error either direction, we don't gain a lot. There's not a lot of confidence gained between 95 and 99.7. But if you go down a standard error, you lose a ton. There's a huge difference between 95 and 68. So the 95% ends up kind of being the sweet spot of where we like to keep things.